Hi, Stats. I wanted to go through the first part of the lesson today with you. You're going to see some similarities here with what you've seen in Algebra 2, hopefully, on this first part and maybe even into the second part. So, we're going to talk about conditional probabilities. That looks like this probability of A given B. We're going to talk about general multiplication rule and tree diagram. That'll be later in the lesson, and independence, which you should have touched upon in Algebra 2 in theory. So we're going to kind of build off this lesson, our taco tongue and evil eyebrow independent. So here's the data from the lesson 5.2. And what we're going to do here is suppose we randomly choose a student from this class. Given the person selected is yes, evil eyebrow. So that's a given condition. So the way I'm going to write this is probability given evil eyebrow. What is the probability that they can, yes, taco tongue. Okay, so I'm only looking at the people who can evil eyebrow. So in this case, my denominator is 6. Out of those 6, 4 can taco tongue, 4 out of 6, or 0.6 repeating. So based off that, pause the video and try number 2. In number 2, given the person is not able to evil eyebrow, so evil eyebrow complement, what's the probability that they can taco tongue? So no evil eyebrow, 14, out of which 11 can taco tongue. So you'll notice what I'm doing each time is I'm starting with the given amount. That's the denominator. So basically, this is like a conditional distribution back from chapter 1. We're not looking at the entire totals like we did for marginal distributions. We're just looking at a part. Another thing I want you to realize, they're not often going to say given. It'll be phrased in a way like a randomly selected student who could evil eyebrow was selected. What's the probability they can taco tongue? Something like that. All right, if we move on to page 2. Go ahead and work through number 3 and then try, based on the definition, to do part C. So pause the video now and work through question 3. All right, so now we have a new two-way table for all seniors at Rush Henrietta High School. What's the probability somebody can taco tongue? There's no given condition, so we're looking at the entire 600 students. 480 can do it. All right, as a fraction, decimal 0.8. Part B, given they can evil eyebrow. So I'm only looking at yes, evil eyebrow, 200 students, out of which 180 can taco tongue, 90%. All right, so this definition, 2 events are independent if knowing whether or not one event has occurred does not change the probability that the other event occurred. So the probability that somebody, a randomly selected student, could taco tongue is 80%. But now I know somebody can evil eyebrow. The probability they can taco tongue is now 90%. So this probability changed. Given that we know that the person can evil eyebrow, they are more likely to taco tongue. So the probability or the events are not independent because people who can evil eyebrow are more likely to taco tongue. Oh, you can't see any of that. My apologies. They're not independent events. So what I'm going to challenge you to do right now is go ahead and try to work through questions 4 through 7. 4 is going to be a little bit of a struggle potentially getting started with it, but keep in mind this definition. If knowing whether or not one event has occurred does not change the probability that the other event has occurred. Keep that in mind because you know the total percentage of people who can taco tongue and can evil eyebrow. You can use either one to fill out the rest of this two-way table. So pause the video now, work through questions 4 through 7, and then come on back. All right, so here's what I'm going to do. I know 80% of all RH seniors can taco tongue. So 480 out of 600 is 80%. So what I want to do is find 80% of the 400, because 80% of 600 is this 480. So I want to find 80% of 400 is 320. So once I find that, everything else is going to fall into place. This is going to be 80. This is going to be 40. This is going to be 160. I could have also done 80% of 200 first to get the 160. Essentially, this is 80%, 80%, 80%. Or if you look at it this way, if you did evil eyebrow is 1/3, that's 1/3, that's 1/3. So probability they can taco tongue, still 480 divided by 600, or 80%. Given that they can evil eyebrow, there's 200 students who can. What's the probability they can taco tongue? 160, because we're only looking at that given condition, is 80%. So what do I notice about the answers? They have equal probabilities. So the generalizing is this. If you have two events A and B, if the probability of A is equal to the probability of A given B, then we say the events are independent. Essentially, given that event B happened, it did not change the probability of A happening. So let's summarize. This is a formula that's on your green formula sheet. It's nice to know. The probability of A given B is the probability of A and B, the intersection, divided by the probability of what's given. We won't force the use of this formula too much, but it is there, and sometimes it can be helpful, especially on these tree diagrams, which we'll get to later in the lesson. In order to prove events that are independent, you're going to use one of these formulas to prove events independent or not. You're going to use one of those two formulas. So go ahead on the bottom of page 3 and do this check of understanding, and then I will go over it. So pause the video now and see if you can do this. All right. Are the events snowmobile owner and environmental club member? So we have S is snowmobile owner, E is environmental club member. So I can use one of these two formulas. Doesn't matter which. So there's multiple ways to do this. I'm not going to be able to show all the ways. I'm going to show one way. This is the probability of environmental. Does this equal the probability of environmental given snowmobile? That's what I'm trying to see. So the probability somebody was in the environmental club, out of 1,526 members, we have, how many were in the environmental club? 1,221, which, let me get my calculator, is about 0.8. 80% of people are environmental club members. Given that people have a snowmobile owner, given that they're a snowmobile owner, so I'm only looking at the snowmobile owners, 295, out of which, oh, I messed this up. Probability that they're in the environmental club is only 305, so that should be about 20%. Yeah, 20% are in the environmental club. Out of the 295 snowmobile owners, 16 are in the environmental club, and that's about 5%. These are not equal probabilities. So essentially, knowing that somebody owns a snowmobile, that did change the probability they are in the environmental club. So I'm going to say no, events S and E are not independent because probability of E does not equal the probability of E given S. A couple other ways you could have done this.